This is section 5.6, problem number 4. And for this problem, we're again going to use that formula that was given at the beginning of this section. So that formula would be P sub t equals the initial population, P sub 0, e to the kt power. Now, let's look at what everything is. So this 2,000, that's our initial amount invested, so that's P sub 0. The interest rate is K, we don't know it. We want it to grow to 2504.65, so that's our P sub t. And then 5 years is our time. So we're going to plug those into this formula. So we get 2504.65 equals 2,000 E, and then the time is 5, so I get 5K power. Now I need to solve for K, so I'm going to divide both sides by 2,000. And then that's going to give me, I'm going to put that in my calculator, and I get 1.252325 equals e to the 5k power. Now I'm going to ln both sides, so I can get rid of that e. And then that goes away. So I've got ln of 1.252325 equals 5k. Now divide both sides by 5 and then put that in the calculator, and you get k is 0.045, and of course when you give a rate you want to give it as a percentage, so it'll be 4.5%, and that's k for answer 1A. So we get 4.5%. Now it wants the function itself, so we're going to put that P sub t equals the initial amount, which is 2,000, e to the 0.045 t power. So there's the function. Now we want to know what will be the balance after 10 years. So we find P sub 10. So that gives us 2,000 e to the 0.045 times 10 power. And then you put that in a calculator, and you get 3,136.62. And that's the answer for C. Now it wants to know how long will it take for our money to double. So again, if I start with 2,000 and I want it to double, then I'm going to have 4,000. So 4,000 equals 2,000 e to the k, which is 0.045 t power. And again, we're trying to find t, so we divide both sides by 2,000. And again, notice that if we're going to find, if we want our money to double, this becomes a 2 over here. So what do you think would happen if we wanted our money to triple? That would become a 3 over there. All right, so anyway, we get 2 equals e to the 0.045 t power. And then we're going to ln both sides. So we get ln of 2 equals 0.045 t. Divide both sides by 0.045. And then put that in the calculator, and you get t equals approximately 15.4 years for that money to double. So now while we're here, let's go to the next page where it starts talking about the doubling time. And notice what we had happen. Each time we got kt equals ln of 2 because of it doubling. So if I'm trying to find the k, which is the growth rate, then I divide by the time, and I get k equals ln of 2. Or if I want to find the time, then I divide both sides by k, and I get ln of 2 over k. So anytime that you're doubling, you can use these simplified formulas instead of doing all that work that I did. Now let's go to the population of Kenya is now doubling every 25.8 years. What is the exponential growth rate? So we're going to use the exponential growth rate. K it's doubling, so it's ln of 2 divided by 25.8. and that will give you K, and you just slip that into a calculator. And then decay is the same way, except for notice with we do get a negative K for the population because it's a decay instead of a growth. What are some things that decay? Well, carbon decays. Also, radioactivity decays, so the isotopes in that decay. So this is our same formula. It's just a negative K instead of a positive K. And the same thing happens with the graphs. The growth is going up, the decay is going down. And then we get to the same formulas. Notice the negative sign is even gone. It's the same formulas to find K and T.